SSE is the sum of a square residual error. Basically, this is an unexplained variation. We have SSR, that is the sum of square regression error. This is an explained variation. SST is the sum of a square error total. For SSE equals the sum of yi minus f of xi squared. F of xi is the regression equation we got from different methods. For SSR equals f of xi minus y bar, that's the mean of the original value. Then you square, you will get the SSR. For SST is the sum of yi minus y bar squared. From this diagram, you could say SST equals SSE plus SSR. Then for correlation coefficient square equals SSR over SST. We can write down 1 minus SSE over SST. In other words, when SSE increasing, then R squared is decreasing. We need to figure out which quadratic model has the smallest SSE. Then that quadratic model will have the greatest R squared, which means the quadratic model which has the smallest SSE is the best fit. We used 4 different ways to figure out the quadratic regression equation here. We want to figure out which one is the best fit. We got to use this SSE to decide. Now, I will show you use Excel to figure out the best fit through SSE. This is the quadratic regression equation given by matrix. This regression equation is given by vertex form. This one given by derivative. This one is given by least squares regression. For this bimatrix, let me write down the function here. So first of all, remember you put the equal sign. And you will put the negative 0.139. For the x squared, you have to put this x coordinate. So you have to put this times. Use a star to stand for the multiplication in the Excel. Then click here, plus, I forgot square. Square, you have to use this symbol though. This is square. Then plus 1.763 times. Click this C4 again. Then plus 2.646, then enter. Then click this cell, find this plus sign, then drop down over here. For the SSE, you will do equal sign here, parentheses. for this y coordinate value minus this value. This is the value by the function given by matrix. Then parentheses back, do the power. Then enter. Still find this plus sign drop down. Then we need to figure out the summation of this SSE for each point. So click here, put the equal sign, sum. It will be from this F4 to this F16. Then parentheses back, enter. You will get this value is a SSE value for matrix. When you say this number E negative 0.9, that means 10 to the negative 9th power. So you can change this into 0. Here you have E negative 0.5 means 10 to the negative 5th power. So we will change this one into 0.2. You will use the same way to figure out SSE for different method. Then you can compare which one has the smallest SSE. That regression equation will be the best fit. Now already figured out the SSE for different form. After comparing these 4 numbers, I found out SSE for least squares regression has the smallest value, which means this equation given by least squares regression is the best fit. I copy the table from Excel. Remember, if you see something E negative 0.5, this is the Excel notation. It's not allowed in our Math IA. You need to change into 0. Then you compare the value of SSE. You will see the quadratic model given by least squares method has the smallest SSE value, which means y equals negative 0.142x squared plus 1.752x plus 2.827 by least squares method is the best fit.